Have you ever pondered why Mars, our neighboring planet, is red? It's a question that has intrigued scientists and space enthusiasts for years. The answer lies in the presence of iron oxide, more commonly known as rust, on the Martian surface. This rust gives Mars its distinctive red hue, much like the color of bricks or dry red earth. But it's not just any rust, it's a particular type that forms in a low-oxygen environment, which is precisely what Mars offers. The iron in the Martian soil reacts with the little oxygen available, resulting in this iron oxide that dusts the surface and paints the planet red. This phenomenon is so widespread that even the skies on Mars appear pinkish red, further intensifying its reddish appearance. So, next time you gaze at the night sky and spot Mars, you'll know why it's nicknamed the Red Planet. Did you know that Mars is home to the tallest volcano and the deepest canyon in the solar system? Let's start with Olympus Mons, the towering giant of Mars, standing tall at 25 kilometers. That's twice the height of Mount Everest, the highest peak on Earth. Olympus Mons, a dormant volcano, was formed billions of years ago by a massive lava eruption, making it a testament to the fiery past of Mars. Now let's descend into Valles Marineris, the deepest canyon on Mars. At a depth of 8 kilometers, it's as if you stacked the Grand Canyon on top of itself and then dug a little deeper. This vast chasm was not created by an ancient river, as one might expect, but by the movement of tectonic plates on Mars. Quite the sight, isn't it? The grandeur of the Martian landscape surely boggles the mind. What if I told you that Mars, despite its barren appearance, hides ice beneath its surface and has its own atmosphere? That's right, beneath the craggy, rust-colored terrain of Mars, a much cooler, slicker story unfolds. Scientists have discovered substantial amounts of ice tucked away under the Martian surface. This ice could take the form of water ice, carbon dioxide ice, or even nitrogen ice. Imagine frozen reservoirs of potential resources, just waiting to be tapped into. These icy deposits could hold the key to future human missions to Mars, providing drinking water and even the potential for growing plants. Now, let's float upwards and take a look at the Martian atmosphere. It's there, though it's not quite like the one we have on Earth. The atmosphere on Mars is incredibly thin, with a pressure that's only about 1/100% of our own atmosphere. This means that the blanket of gases enveloping Mars is far less dense than Earth's, making it a less hospitable environment for us humans. What's in this thin Martian atmosphere, you ask? Well, it's primarily composed of carbon dioxide, a compound we here on Earth associate with fizzy drinks and photosynthesis. But don't be fooled. Though carbon dioxide might be key for plant life on Earth, the high concentration in Mars' atmosphere doesn't quite create the same lush green landscapes we're used to. However, the thinness of the Martian atmosphere doesn't mean it's uninteresting. On the contrary, it's a subject of great fascination for scientists. The atmosphere's interaction with solar radiation, its effect on surface temperatures, the potential for weather phenomena, all these aspects are under intense study. So, as we gaze upon the red planet's desolate beauty, let's remember that beneath its surface, icy secrets lie in wait, and above, a thin veneer of carbon dioxide-rich atmosphere whispers tales of a world very different from our own. Even though it's not as thick or as warm as Earth's atmosphere, Mars does have its own unique atmospheric composition. Ever wondered how time flies on Mars? Well, it's a bit different from what we're used to here on Earth. A day on Mars, also known as a sol, is only slightly longer, clocking in at 24 hours 37 minutes and 22 seconds. That's right, a Martian day gives you a little over half an hour more than an Earth day. You'd have a bit more time to cross off those daily to-dos, wouldn't you? But when it comes to years, Mars really stretches things out. One Martian year equals 687 Earth days. Imagine having a birthday or anniversary only once every 687 days. This difference is due to Mars's elliptical orbit, which takes longer to travel around the Sun compared to our own circular orbit. So if you ever plan to keep a Martian calendar, remember, it's going to be a bit longer than ours here on Earth. Mars, like Earth, is not alone in its journey around the Sun. It's accompanied by two loyal companions, its moons Phobos and Deimos. Named after the Greek gods of fear and panic, these moons are quite different from our own moon. Phobos, the larger of the two, is so close to Mars that it orbits the planet twice a day. It's not round like our moon, but more of a lumpy, potato-like shape. Deimos, on the other hand, is even smaller and further away, making a complete orbit in just over 30 hours. Despite their size, these moons have a significant impact on Mars. For example, Phobos is gradually spiraling towards Mars, and it's predicted that it will either crash into the planet or break apart to form a ring system in about 50 million years. Though smaller and closer to their planet, these moons accompany Mars in its celestial dance. Could Mars have once harbored life? Scientists believe it's a possibility. Eons ago, the red planet might have had an environment capable of supporting life. There are traces of ancient rivers and seas etched into its surface, suggesting that water, the lifeblood of our own planet, once flowed freely on Mars. The composition of Mars's atmosphere also provides tantalizing clues. It hints at a past where water vapor could have been abundant. Perhaps the most compelling evidence comes from Martian rocks. Some of these stones bear a resemblance to those formed by life on Earth, further stoking the fires of speculation. Yes, the red planet is a place of extremes, with towering volcanoes and deep canyons. But these extremes could have once been tempered by the life-giving properties of water. While we have yet to find Martian life, the clues we've uncovered continue to fuel our curiosity. Mars isn't just a scientific curiosity, it could be a stepping stone for the future of human space exploration. It's the most Earth-like planet in our solar system, making it an intriguing target for our exploratory missions. Over the years, numerous spacecraft have journeyed to the red planet, each one peeling back a new layer of the Martian mystery, revealing information about its surface, atmosphere, and the ice hidden beneath its crust. The allure of Mars goes far beyond its similarities to Earth. It's about the potential it holds for the future. The ice on Mars could be a vital resource, providing drinking water and a means to grow food. It could also be used to create rocket fuel for missions venturing farther into the cosmos. The metals and minerals found on Mars could be used for construction and energy generation, reducing the need for costly and resource-draining supply missions from Earth. But the potential benefits of Mars exploration aren't only tangible resources. Mars could serve as a base for future interplanetary travel, a stepping stone on our journey to the stars. It's a shorter trip to Mars than to many other potential destinations, making it a logical first stop. And establishing a base on Mars could provide invaluable experience and knowledge before we take the next leap to more distant worlds. Furthermore, the possibility of life past or present on Mars is a question that continues to captivate us. If life once existed there, it would revolutionize our understanding of our place in the universe. And if Mars could support life in the future, it opens up exciting possibilities for human habitation. In the grand scheme of human history, we are just at the beginning of our spacefaring journey. But every journey begins with a single step, and Mars, with its red, rust-tinged surface and intriguing potential, could be that first step. As we continue to reach for the stars, Mars could very well be our first stop. Could Mars be a new home for humans in the future? It's a thrilling yet daunting prospect. As the most Earth-like planet in our solar system, Mars presents a compelling case for future human habitation. The planet's surface is rich with metals and minerals, potential raw materials for construction and energy generation. Below the surface, vast reserves of ice could provide drinking water and irrigation for plant growth, making self-sustaining colonies a possibility. But it's not all rosy. The thin atmosphere and frigid temperatures pose significant challenges, requiring advanced technology and innovative solutions for human survival. And then there's the issue of getting there, a journey of approximately 54 million kilometers. But with every new discovery, every successful mission, we get one step closer to turning that daunting prospect into a thrilling reality. While it's still a distant dream, the thought of humans living on Mars continues to inspire us to explore the cosmos.